Okay, live and recording. So hello everyone and welcome to this Kubernetes Operators panel. Thank you for being here, for investing your Friday afternoon, morning or evening or even night, wherever you are, with this. I have to say that I'm very sorry, but we are only going to have 6 people every time on stage. But we will try to do our best to have everyone with the same amount of time with what they have to say. Okay, first of all, I'm going to introduce who is really hosting this event, that it is the Barcelona JUG, Java user group of this amazing city. I'm going to kick off one of you randomly. That's okay. That's it. Okay. Application window. Let me check. Okay. Apparently, you should be seeing the beautiful Barcelona JUG logo. If anyone can check that YouTube streaming is also working, it will help me a lot. Okay. So we are the Barcelona Java users group. And first of all, well, we are a bunch of people. Now we are almost 1,600 members in Meetup, and we've been running this this community since 2012, so 9 years. And we usually host events every month. Some months 1, some months 2, or even 3 events. Now with this virtual thing, we tend to host many. So we get together to discuss about frameworks, tools, and technologies, mainly related to Java, but I would say that not only to Java. So we've been covering lots of stuff. I will give you a hint in a moment. These are our links, so you can just use. The Meetup one is the most active. You can use also the Twitter account, Slack to share your ideas or be in contact with the community. And go to YouTube and check the videos from the past conferences that we organize, or even meetups like this one. Also, you can go to jvcandconf.com, that it is the main website for the conference that we host every year. But unfortunately, in 2020, we couldn't do it. And you will be notified about the next steps with the next editions. Some past events that we've hosted, well, from Docker to Camel, Kubernetes, Spring, Quarkus, Neo4j, so lots of technologies. We are very proud of our past JVC&Conf 2019 that we had, and with more than 700 attendees and more than 70 speakers. That was a very nice one. And these are a bunch of pictures in order for you to have a magnitude. You will see someone, I think, on stage that can be familiar. Well, we are very proud of this edition, and we cannot do it without all the team and the members that are helping and investing a lot of time in doing this. So thank you, everyone. Our next event would be next week. Yes, about BDD, Cucumber in this case. With Catalin to those that will be sharing with us, well, how to do a proper BDD and using, in this case, Cucumber. So a very, very interesting one. I need to thank Jakarta. This is our streaming sponsor. So for giving us this Crowdcast connection that, well, we can get to you virtually. So if you want to join us to suggest topics, or even to suggest giving a talk, just please reach us and we will try to arrange it. And nothing more from my side. Today's event is about Kubernetes Operators panel. We have several people, 10 speakers from different companies. And well, we have Adam Sandor, Alberto Calleja, Álvaro Hernández, Attila Mezzaros, Bella Bay, Christophe Laprun, Jakub Scholz, James Strachan, Jesús Rodríguez, and Marc Nori, that they are going to, well, to talk about different elements or topics about Kubernetes operators. The agenda is the one that you see here, so a self-introduction for everyone. Then how and why they create operators. Then we will talk about tools to scaffold an operator. Okay, so if I want to start an operator, well, something that creates everything for me. How do they handle events and reconciliation process for the operator? How do they test their operators, and what do their SDKs that are present today are offering in the test topic for an operator? And then finally, the deployment and publishing that operator, where, using what? So, well, using Helm or Jakub, or even in repositories like Helm Hub or Operator Hub, how do they publish their operators and with which files? And finally, what's next, what they can provide for the next months related to operators, and conclusions about, well, wishing list for their operators or proposals for the wishers, let's say. So let me find, okay, where is it? Here, okay. Okay, so I will try to follow the agenda and add 1, 2, 3, 4, 5. I need to add one more. So I will add by alphabetical order. So I will kick off those that are not deserve to be now here. Sorry. Okay. Okay, and now I will add Alberto. Álvaro. Okay. Attila. And Bella, I think we are set, right? Okay, perfect. So first, you have 3 minutes of self-introduction, and then, I don't know, highlight anything that you want to related to operators. So first, it's your turn, Adam. So it's, yeah, just simply go ahead and present yourself.
Yeah, hi everybody. I'm Adam Sandor. I work for a cloud-native consultancy company called Container Solutions. So our mission is to, well, bring cloud-native technology to everybody, which is mostly Kubernetes and Docker and everything around that. So operators have been on our radar for a long time, but this is the time when they really seem to be taking off also for automating internal infrastructure at different companies. And about 2 years ago, together with Attila here, we were working with a client to automate a big CI/CD system, where we decided we would like to do this with operators. It would be a great use case for them, but we are Java developers, so we were like, yeah, we don't want to just learn Go for just this case. So we started implementing a bunch of operators in Java and spun off an open source project called the Java Operator SDK from that. And ever since then, we are building this project now together with some people from Red Hat, and yeah, we would like to see an uptake in the Java community to see more Java developers build operators. That's it from me.
Nice. Thank you very much. Alberto, tu turno.
Yeah. Okay, so my name is Alberto Rios. I'm based in Seville, Spain, and I joined VMware through the Pivotal acquisition. So I'm here in a personal capacity, by the way, not representing my employer. So what I say is what I think. I'm part of the Spring engineering team, and my job is to commercialize some of the Spring Cloud products on different platforms by adding some of the integrations, data operations, and security. So over the past few years, our team has been working a lot with Cloud Foundry, but less than a year ago, we started working with K8s. So after we just released the first version of the product last week, actually. So we are very new on this, which is a developer-friendly API gateway. You're interested in that, ask me later. When we were tasked to think about Kubernetes, we just look around and saw that in VMware and in Pivotal, people were building their operators by using Golang. But we took a better look to see why not in Java. I mean, our team has a lot of experience with it. We had already a lot of business logic built in for Cloud Foundry in Java, so why not reuse a lot of the things that we knew? And we saw that there were a lot of initiatives around, a few clients even. So we started to go for Java, and it was working well for us, to be honest. Yeah, it's really nice to be here, actually. Also, because sometimes I chat with Jonathan, and just to compare ideas on the approach that we follow each other. So it's been really nice, and happy to be here. Thank you so much.
Thank you very much for your sharing. Álvaro, your turn. Adelante.
Okay, thank you. Gracias. So, hi everybody. To put it very simply, I'll not speak much about myself. I am a Java and Postgres person. I'll share with you the link to my bio just in case you're interested. But about what we're doing here is because we're at my company, which is called OnGres, which means on Postgres. So basically everything that we do is Postgres related. We have built an open source software called Stackgres. I'll also share the link. It's stackgres.io. It's pretty simple. And Stackgres is an operator for Postgres. So it's a way of running Postgres on Kubernetes. Basically, there's three main things I want to bring today related to this development, to Stackgres. The first one is that we consider it is just more, it's not just an operator, it is a quite advanced platform for running Postgres on Kubernetes. It is very advanced because I'll speak a little bit about this later, we are very senior programmers, and we wanted to automate a lot of things. So not only we have automated deployment of not only Postgres, but all the tools that Postgres requires around it, which is you need connection pooling, backup tools, monitoring, and many others. We have all integrated with an operator, and it's make it very easy to deploy all the stack together. But also because we've gone a long way into automating what it's called typically day 2 operations. So we have automated operations such as minor version upgrades, major version upgrades, security upgrades of the operator, running benchmarks, doing maintenance tasks of the database like vacuum, a PG repack, and a few others. So everything is automated. The second thing I wanted to bring on to the table today is that everything is CRD based. So we're trying to expose very high level interfaces. One of our goals is that Postgres can be quite complex to operate at enterprise levels, at production levels. And we want to reduce this barrier and make it very simple to operate as long as you know how to write a CRD or apply a YAML file with kubectl, right? So that's our second thing that I want to bring on. And the third one is that, like my colleagues that came just before me, we decided to write this operator in Java. It's a quite complex project, so it's more than around 60,000 lines of Java code already. With some abstraction code, which we call that operator framework. So I'm sure there's going to be a pretty nice conversation here going on.
Sounds awesome, and as you say, we are going to have a very interesting conversation, I think. Okay, Attila, no, Álvaro, yeah, Attila, it's your turn. Okay.
Yeah,
now,
thank you.
Yeah.
We are muting and unmuting each.
Sorry.
Hi everybody. I'm Attila Mesaj. I'm currently working from free. I moved here recently. Before I was, as Adam mentioned, together we basically 2.5 years ago created the Java Operator SDK. It was basically a our goal at that time to solve some common problems for the operators. We were writing multiple of them to OpenShift platform, and just make it easy to implement operators in Java. So today I mostly will maybe talk about the journey on the certain panels, how Java Operator SDK solve some issues, some common issues with operators, and and related problems. So basically, that's it from me.
Okay. Thank you very much. You've been quick. Thank you. Okay. So now realize this is the stage is yours.
Whoops. We unmuted myself again. Hi, I'm Balabai. I'm based in Boston, Massachusetts, in the United States. I joined VMware through the Pivotal acquisition about a year ago, same as Alberto. And I joined Alberto's team actually 2 years ago. And before that, I was a consultant for a few years, working across industries like healthcare, insurance, financial services, or retails, and helping them to be more cloud native. Now my team is aiming at improving cloud experience or Kubernetes experience for developers, and we commercialize Spring Cloud products in different cloud platforms. Like Alberto mentioned, CF is in the past and Kubernetes is the now and probably the future. And these two technologies are quite different in terms of design principles, ecosystems, and user experience, which is cool because we get to see the best of both worlds and apply learnings from one to another. I'm super happy to be here and meet all of you and get to learn from what you're working on, how you're doing things, and maybe identify some of the common problems we can brainstorm on. Thanks for having me.
Yeah. Okay, it's a pleasure to have you here. Thank you very much. Okay, so now it's turn for the second bunch of people. So see you in a bit. Okay. Well, this makes everything more interesting. Okay, so we are going to add Chris, Jakub, James, Jesús, and Marc. I think we are all. Yeah, we are waiting for Marc. Okay, perfect. We are the next bunch. Okay, so now it's turn for Christophe. Chris, the stage is yours.
Thank you, Jonathan. Hi, everyone. I'm Christophe Laprin. I work for Red Hat. My interest in operators is basically around developer experience. Try to automate things as much as possible. I mean, as probably many of you know already, Kubernetes is quite a complex beast. And so I feel, and I think many of us do feel like that, that there are ways to probably improve the user experience there. And I think that goes through custom resources and operators so that you can create higher level abstractions or things that are closer to your users' concern as opposed to the technical concerns that Kubernetes has. So that's kind of the core of my interest in operators. I worked on one such operator in Go, but I'm a Java developer at heart. So when I heard about rumblings about writing operators in Java, I took the leap and I tried to work on that. So I'm currently working with Adam and Attila on the Java Operator SDK, and more specifically the Quarkus extension for it. Because we, at least at Red Hat, we think that Quarkus is kind of the best of both worlds, where you have the, I mean, I guess people from the Go land might disagree, but people from Java land would argue that the developer experience in Java is a little bit nicer than in Go. And so the best of both lands, meaning that you have the nice Java experience with the ecosystems of the vast ecosystems of libraries and things like that. But with Quarkus, you can get the native runtime capabilities that Go has. So we feel like, yeah, that's really the best of both worlds in that sense. So yeah, we are trying to make it as nice as possible for people to write operators in Java and make them perform quite well. And yeah, that's it for me.
Jonathan, I think you are muted, but I guess it's my turn now.
Sorry. Yes, it's your turn.
Right. Thanks for having me here. My name is Jakub. I work for Red Hat from Prague, Czech Republic. And I'm one of the maintainers of the Strumzy project. Strumzy is a CNCF project which is focusing on running Apache Kafka on Kubernetes. Probably most of you heard about Kafka already. And originally, long time ago, we started really as a bunch of YAML files for deploying Kafka on OpenShift and Kubernetes. But quite quickly, already at the end of 2017, early 2018, we realized that that was not enough and that we needed something more and moved to the operator pattern. And really, our main goal is to make running Kafka on Kubernetes feel really as kube native as possible. So we do not really support in the operator only all the kind of Kafka server components like the brokers and Kafka Connect and Mirror Maker and so on. But we also, for example, have operators for managing the things inside Kafka, such as users, topics, or Kafka Connect connectors. And when we really started with it, I don't think there were any frameworks yet. Even the Golang one didn't exist. And in the team, we had really more experience with Java than with Go anyway. And Kafka itself is in Java and Scala, so that fit there quite well as well because all the APIs were in Java. So yeah, we decided to write it in Java, and since then, basically the Strumzy operator is written using the Vertex toolkit and using the Fabricate Kubernetes client, which I think both work amazingly well for us. And yeah, I think that's a good experience for working in Java. Hopefully now improved more and more with the frameworks and SDKs.
Okay, thank you very much, Jakub. James, your turn.
Thank you. That's a good segue mentioning the Fabricate Java client. That was probably the last thing I worked on when I left Red Hat. That was my last.
You know something about that.
Perfect timing. So hey, I'm James Strachan. I work at CloudBees. I focus very much on helping developers do CI/CD. I work on an open source project mostly called Jenkins X, which helps automate CI and CD for Kubernetes clusters. And I'm a huge operator fan. I mostly use operators. I don't really develop them that much, but I'll talk about a couple that I've worked on. But I'm mostly a user of operators, and I love them. I love the fact that we can essentially extend the Kubernetes ecosystem to cover anything. I mean, we've talked about Postgres and Kafka already. So some of my favorites, Cert Manager and External DNS for managing TLS and domain services. External secrets is one we use a lot on Jenkins X for bridging secrets from, say, Vault or cloud secret stores to Kubernetes, so that you can write a simple Kubernetes application that focuses on Kubernetes secrets, and you can leave all that horrible Vault stuff to the operator to deal with, because Vault's good, but painful to work with. So operators take the pain away, basically, and extend the platform, which is awesome. There's a zillion operators out there. There's all the service meshy stuff and various other kind of things. A couple of operators I'll just call out that I use or work on a lot. What we use in Jenkins X, which we really, really like, is something called a Git operator, the JX Git operator. I'll post a little. I'll put a couple of slides there. I'll just put there's links in the slides. But basically, the Git operator is super, super simple. So it's nowhere near as complicated as things like Flux or Argo. But it basically just triggers a Kubernetes job when a Git repository changes. So it just watches Git, and you can check into Git anything you like, and it triggers the job that's defined in Git when Git changes. So it's a simple, think of it as like a cross between cron and GitOps. It's a way of running anything you like, defined in Git when Git changes. So you could do a poor man's GitOps by doing kubectl apply whenever Git changes, or you could do Helm install or customize or whatever. So we use that simple Git operator that just runs a job to install everything in all of our clusters. We use that to install Jenkins X itself. We use that to manage all of our staging and production clusters. It's really, really simple, but it just does what it says on the tin. It's super, super easy. Another operator we use quite a lot. So you mentioned earlier, Jonathan, how do you test operators? So we've struggled testing operators. Operators often are cluster scoped. So you can't really test different versions of an operator in a real cluster. So a lot of people test operators in Kind and things like that, and Docker, and we do like a pretend Kubernetes cluster and test it there. When we're testing like a full CI/CD with Kubernetes external secrets and TLS and cert manager and external DNS and all of these things, we need to really test things. We need a real Kubernetes cluster. We need real cloud infrastructure and cloud resources. We need real buckets. We need real storage. We need real databases. So we tend to use Terraform to spin up temporary clusters and temporary cloud infrastructure. Then we test the thing we're testing inside, which could be an operator, it could be Helm charts, it could be anything. It's stuff. We test stuff in that cluster. Then we tear it all down. And there's an operator I mentioned towards the end of those slides, like slide 5. There's an operator called a Terraform operator, not to be confused with HashiCorp's Terraform operator, which is based on Terraform Cloud. There's another operator called the Terraform operator, which just operates Terraform in Kubernetes. And it's literally a CRD called Terraform, that when you make a Terraform CRD, it does Terraform plan, Terraform apply for you in the job. And then you can run stuff after it completes. So you can run your tests inside the cluster that's just spun up. And then when it's complete, you can just delete the CRD and it tears everything down again. So on every pull request, we spin up many, many clusters with lots and lots of cloud infrastructure with all these different tests in different kind of clusters and different kind of clouds. And then everything, thankfully, garbage collects down so we don't have horrendous cloud bills. And that's the Terraform operator. It's an amazing thing. If you're ever trying to test like real stuff, like real Postgres or real storage or real Kafka stuff, you're going to want a real cluster to do that. So Terraform operator is awesome. I can highly recommend it. Okay, that's me. I'm probably talking too long already. I'm glad to be here.
You were muted.
Jonathan.
Come on, man. The stage is yours.
Okay. Hello, everyone. I'm Jesús Rodriguez. I'm a principal software engineer at Red Hat. I've been here a long time, 17 years, and working on various products here. Right now, I'm the team lead for the Operator SDK. The Operator SDK is a command line tool that helps operator developers scaffold out and start creating operators. We also have plugins to help generate Go, Ansible, and Helm operators. We've been looking at other languages, Python, some hybrid ones where we want Go and Helm to be used, and Java, which is my interest here, why we're here. The SDK also offers the ability for developers to run their operators in testing environments. We also have Scorecard, which is a test framework to allow you to do bigger tests and run them in clusters like James was saying, a similar thing. We also have, we integrate with KubeBuilder, which is a project that we use to do the Golang plugins, and controller runtime is the runtime tool that we use behind the scenes to interact with the cluster. There is a unit test framework that we have for operator developers called env test, that spins up a Kube API server and a controller that you can kind of interact to give you a simulated test framework, or at least test environment for unit testing without having to use a fake client and create all your objects that way. And the primary focus too for Operator SDK that builds on top of KubeBuilder is we also integrate with the Operator Lifecycle Manager in OpenShift. So we make it easier so that you can package your operators and run them in OLM and test them that way. So that's primarily one of the use cases for Operator SDK. That's it for me. Happy to be here with everyone. You're still muted.
I don't understand. Okay. Marc, a teu torn. Your turn.
Okay, so I'm Marc. I work as a software engineer for Red Hat, and I'm currently maintaining the Fabricate Kubernetes client and the Eclipse JCube. So Eclipse JCube is the inheritance of the Fabricate Maven plugin. So those are both projects two projects that James was working on. So I'm really happy to work on those projects. And well, I think that most of the things that, or you said that we wanted, what kind of message we wanted to give to the audience here, and I think most has already been said, but operators are now taking off, and it's really something. And what I want to transmit to the audience is that you can build operators in Java too, and also if you could build them using any of the tools that depend on the Fabricate client, well, even better. So another of the things that I would like to say is that the Fabricate Kubernetes client tends to be a community project, and what we want is that people get involved and contribute. So amongst the speakers, there's already some people who have already contributed to the project, and I'm really glad to see that many more people are contributing every day. So those are my two main messages to give. And yeah, that's it. Mute, you're on mute.
I don't understand why I mute them. So sad. Okay. It's very interesting to have all of you here and sharing all this information, and I'm enjoying a lot. I hope that you are also enjoying. I have created some polls for the audience. If you can please visit them and just to have an idea of which is the usage or the creation of operators, just please answer them. So, okay, we are going to start with the how and why I create operators. And for this, I'm going to politely kick off Chris, see you in a minute, and also Marc, see you in a bit. So we are going to have, okay, Jesús, see you in a moment. And I need to invite Bella. And I need to invite Attila. And Álvaro. Okay. Perfect. So now we have a around 20 minutes. The stage is yours. I will mute myself now, and I will try to unmute at the end. The stage is for all of you, so be unmuted and jump in with your thoughts. I can suggest going in order. So in my screen is Jakub, James, Bella, Attila, and Álvaro, but the stage is yours. Just use it.
That sounded like I should start. So yeah, it's probably the first thing which I always do is try to think, why would I want to run the application on Kubernetes? And I know it might sound a bit like heresy, because I mean, what, running applications outside of Kubernetes? But if nothing else, I think it's quite important to understand why do you want to do it, because it helps you to define the direction and the focus. What's the most important thing for you, and what should maybe the operator start doing at first? Because yeah, at the end, the operator is not something that is written in one day with all the features. So yeah, you need to have more focus somewhere on the beginning. And then I think obviously the complexity is quite important for deciding whether it makes sense to write or not write the operator. But I think one important aspect is also what James mentioned in the introduction about using all the different operators and building on top of them. Because the operator, on one hand, it can remove the complexity and kind of help the real human operators run stuff, but it also provides good and stable APIs which the other applications can build on. And I think that's an aspect which is often not that visible, but which is quite important as well.
James, what do you?
I guess I'll jump in. I'm next on the screen. I was just going to mention something slightly different, but related to what you just said. For me, the thing I love about operators and Kubernetes in general is there's a single command line interface, REST API, and there's a single way you can do GitOps for everything. So whether you're doing Kafka or Postgres, or you're doing, whatever you're operating, something that's Quarkus-ish. You could be operating normal Helm stuff. You could be operating anything on Kubernetes, Istio. Anything has a CRD now, a custom resource. And so in a Git repository, you can store all of these resources for all of the operators. And then you can version them. And then how you actually apply those operators, you could use kubectl. There's a whole raft of tools. We use the Git operator on Jenkins X. You could use Flux. You could use Argo. You could literally do a cron job that does git clone on the cron job and does kubectl apply. VMware has a really good tool, by the way, called CAP with a K, K-A-P-P, which is like kubectl apply, but it's smarter because it looks at all of the operators and the finalizers and the dependencies between the CRDs and decides what to deploy in what order and waits for things to be ready and stuff. Because let me talk about a quick thing about downside of all of this complexity. In the early days, everything was simple. You just kubectl applied a bunch of resources and everything worked. I love operators, but there is a slight complexity that they introduce. For example, let's say you're using Nginx. Nginx now watches for ingresses, and it has admissions webhook controllers and mutation webhook controllers. And if you accidentally bounce your Nginx pod, you can't use the CRDs anymore. So sometimes CRDs can only be used if the operator's up and running. If you've got 20 operators in a cluster and you do kubectl apply, it's kind of random knowing if it's even going to work, because you might have just taken down an operator, so you can't change. So some CRDs can be changed because the operator's running. Others you can't touch them because the CRDs are not open source. So I love Kubernetes, I love operators, but just be slightly aware that the use of CRDs works beautifully in GitOps, but you also need to be slightly careful of ordering to make sure all of your operators are running before you apply those custom resources and stuff, which is like the operational complexity of operators. Trying to get all of the operators to work nicely together with GitOps can be a little bit of a challenge. It's not hugely complicated, and CAP is my favorite answer, by the way, from VMware. It works beautifully. And then you can just annotate things to make sure CAP understands the order. So you don't apply the CRDs until the operator's running, basically. And you just make sure everything's in a nice sequence. So you can tear down your entire cluster, you can bring it all back again, and everything works first time, rather than the other option. You just keep kubectl applying until it works, which is the other option. Anyways, that's me.
Yeah, and just following on that, you mentioned a multiple VMware project, and I'm very familiar with that, and I completely agree. And to your last point that you says you need to make sure your CRDs are applied in a certain order before your operator is up and running. And we actually had that problem. So we ended up, we were using Helm chart to deploy our product, and then we split that into two different charts. One chart is only for CRD, the other chart is for the operator. So we make sure there's a dependency between these two charts, and then we would definitely apply all the CRDs before we bring up the operator. I completely agree, every sentence you said. And to me, I feel, when do we use operators? Like Kubernetes is amazing. Like it's very helpful. Like it's leveled and everything is depending on the state, and then you just you only need to check the differences. However, it's not super user friendly. Like for normal developers that writes application code, they may not have time to figure out what to do with Kubernetes. That's why all of us is trying to create operators, create products that make their life easier. And if we want to do that, we probably just want to provide them CRDs and let them apply them, and then we do all the complicated magic behind the scene. And sometimes manifest is enough, like applying all the things is enough, like templating is enough. But a lot of time we need ordering, we need transformation, we need validation, we need a lot of those things that only operator can help us to make sure everything happens in the right order and right with that right value. And that's why we are using operators, and I feel that's why a lot of people are using operators, just because template only gets us that far, and then the additional mile we have to use operator at that point. That's my opinion on why should we create operators.
Can I just jump in really, really quickly to something Bella said right at the beginning, that we found expecting developers to put things in Helm charts at the right dependency tree level. So, you know, you put ingresses separate so that you can install Nginx first, then your ingresses in the chart. And then if you try and decouple everything into Helm charts so you can beautifully order things, it's never going to work, because developers don't understand these dependency trees between charts and operators and CRDs and whatnot. So what we tend to do on the JUG project is, you give us all the charts you want to deploy, and you just give us anything, like Kafka and Postgres and some other things, and then we basically Helm template everything, and then we let Cat figure out how to install it, because it's just too complicated. No human can figure this stuff out. You kind of need a tool that can go through your entire tree and go, right, let's do the cluster level stuff first, then we'll do the CRDs, then we'll do the cluster level resources, then we'll go through all the different namespaces, and then figure out what's the dependency tree before you kubectl. So never use kubectl, use cap is the quick answer. Use Helm template and cap. It solves so much pain, and it saves you asking your developers to keep changing their Helm charts, to move bits out, move bits over there, and then put it over there and disable things, because it is quite complicated. Even just using Kafka, Nginx, and Cert Manager, just those three, there's complicated dependency trees between just Ingress and Nginx and Cert Manager and external DNS. Never mind if we get onto Istio and all the other kind of complicated stuff. Sorry, but over to you, Attila.
Yeah, sure, no problem at all. Yeah, so why we use operators? Maybe I start with a story why we started to use operators, and it might be very helpful. So basically about 2.5 years ago, which was a little bit different world, but not that much different, we had a kind of a project working on an OpenShift cluster. And our goal was to build up the CI/CD and all the related resources, running even some pods and deployments, Jenkins pipelines, folders, managing repositories. And that time we are thinking how to do this, and there were two options on the table. One is to somehow magically hack it into the Terraform plugins and implement the Terraform plugins, which we didn't really work out, because first of all, this was a heavily built company which is heavily building on Java, and they didn't really like it that much. Other ones, the OpenShift provider at that time in Terraform wasn't really in a good shape, I think. But I mean, we found some issues. So basically the plan B for us was just writing operators, and this had to be on a very large scale. So getting teams on our CI/CD platform and our solution in a large scale, so about 150 teams. And so we was sure we are not going to do it with some kind of scripts or something. We really wanted to manage some resources which represents the target environment. Maybe it's some kind of sub-resources of that environment. And the ideal kind of on-the-plate solution seems to be Kubernetes Operators, first of all, and we then basically started to do like that. And it turned out to be quite simple to write those, but there were some common problems. So we're writing operators like adding finalizers and making about some transactions, resource versioning, kind of some optimistic looking issues. And that's why we actually created later the SDK and the framework to basically solve these common problems. The good thing was that actually these custom resources, our custom resources, what really made a nice abstraction, and it basically the user who just wanted to just create these resources was just able to add these custom resources, and all the magic behind what's happening was just hidden, and it was super easy to manage. Even upgrades and changes using these custom resources was then easy to manage in the background, just implementing the operator and changing the operator. So that I think this is kind of a really powerful thing, that it hides the complexity from the user, and Kubernetes gives a quite good job to already providing the API. You don't have to think about the API of your resource-oriented resource-oriented API, and all the permissions, the access rights management with custom resources is already there with a very familiar environment, and you are already working on Kubernetes. So I think that's quite reasonable to use all these use cases. Yeah.
What's your saying, Álvaro? You're mute, by the way. Now it's you who's mute. It's not me. No, I will unmute you. Okay. No, you're now.
Okay. All right. Thank you. So I'm going to just briefly step back a little bit, and I'll answer the question also of why we're using Kubernetes first place, because it's still a little bit mystical for some that you're running a stateful workload such as a relational database on Kubernetes. So basically, the way we started looking at this is that we, at our company, we provide Postgres professional support, many companies, and we love automation. We love IAC, infrastructure as code. And we realized that, deploying Postgres on your laptop is as simple as apt-get install Postgres. Done, right? Like super simple. However, deploying Postgres with production quality requires a lot of components, a lot of tight integration, a lot of configuration, and at the end of the day, a lot of expertise. And while we're doing Ansible and Terraform and any other tool for AAC, at the end of the day, because environments are different, we end up creating different code. It was difficult to reuse. So we're doing different project for every customer, and that was painful. And we thought how we can unify this and create kind of a single distribution, because at the end of the day, we're packing so many components, we actually call that a Postgres distribution. So how we can deploy and distribute this Postgres distribution as a single unit, as an RPM package, or several at least, right? If you want to call it that way. And we found that Kubernetes was the only answer to this question, because it unifies disparate infrastructure behind a single API. So by programming against this API, and that's what Kubernetes is for us, is an API, we can package this and distribute a single distribution, right? Not create dozens of distributions for different environments. So this is in the first place. And we knew the databases run very well on containers. We had production workloads running on containers, and that's a non-issue. Now, about operators themselves, well, the answer is pretty simple in our case, because if this stack is so complex, deploying this stack with just YAML files and crafting them and setting parameters will be quite difficult. Actually, if you would look at the equivalent of the YAML file generated by deploying a Stackgres cluster, it is in the order of dozens of thousands of lines of YAML code. It is something that you cannot do manual at all, right? You need some automation to create this calls to the API. And so we build the operator based on these premises that we need to automate this. But one aspect that I believe is very important, I want to highlight that Attila, James, particularly you all have mentioned before, is James said, like, you can deploy with a single tool. With kubectl, you can deploy a Postgres or a Kafka cluster. And that's very important. We call this, well, not we, but we refer to this as cognitive burden, right? Like any technology in general has its own cognitive burden. You need to learn this technology to be able to deploy it in the general case, right? However, with Kubernetes operators, specifically if the CRDs are well designed, they abstract away all the complexities of the technology and expose like a very high level interface, then anyone just knowing the basic Kubernetes principles, how to deploy YAML file, Helm chart, whatever, can deploy these tools. So that's actually one of our goals, and we have made a great effort of creating, first of all, several CRDs, not just a single big fat CRD, but several. For example, Postgres configuration is a separate CRD, which you can reference by name, but internally it's strongly validated. We use webhook validators. We use mutators also to inject default values to provide a tuned config. But we always be very careful that all these CRDs are very high level. They hide all the complexity behind Postgres. So we've tried to build all the what we consider, of course, are the best practices for deploying Postgres enterprise production quality workloads behind the scenes. And what you see as a user is very simple interface. Obviously, we also love tuning, and we also expose low-level details for those that want to go down there. But even those low-level details, they're not just, you want to write a PG bouncer config file, just drop it on a config map, which has to have this name. No, we provide CRD for that, and we strongly validate the CRD. So even you can tune low-level details, they're still abstracted away, and this also level of interaction in the future allows us to build more complex validation or transformation schemes. And in the future, if we, for example, want to replace this connection pooler by another one, we can do it with a minimal disruption from this perspective. So I think this is very important. We want to enable anyone that is a Kubernetes user to become a Postgres expert. And Kubernetes is by operators and with proper abstractions on the CRD level is enabling us to do this.
I will summarize this, but we are going to talk about this in next topics. But if just simply say yes or no, if you agree with me, that we can summarize that Kubernetes and also operators are giving easiness to install or to deploy to, let's say, customers or users. So if you are providing if you are providing applications to run in Kubernetes, definitely is the way to go to make it easier for anyone to use your tool. I think you are all agree with me. Okay. Okay, I will kick you all off. I'll see you in a minute. Let's give opportunity for the next ones. See you. Okay, I will add our next bunch of people. That it is Adam. I also have to add Chris. And also Jesús.
I'll turn on some more lights here. Getting dark.
And Marc. Yeah, I think we are all for this topic. Okay, so this topic is about tools to be used for an operator and to scaffold an operator. We have 15 minutes, so I will suggest to go by order and how you appear in my screen. So Adam, Chris, Jesús, and Marc. But just simply jump in whenever you have something to say, and let's try to make it this as fun as possible. So Yeah, about tools to scaffold an operator. Adam, it is you have the first word and the stage is yours.
Okay, thanks. Yeah, so both me and Chris are working on the Java Operator SDK. So Chris, just feel free to jump in to add things and whatever. So yeah, scaffolding. So it's on one hand important for people writing a new operator, especially if they're new to creating operators, to be able to get going quickly. I see that really as an trend with lots of projects these days, that they just want to get like users go super fast to just to not have this barrier. We have neglected that part for a long time. Actually, on the Java Operator SDK, we were more focusing on the core framework features of handling events and finalizers and all these things. But lately, we start to catch up with generating CRD YAMLs from the Java classes, because that's a bit of a hassle there to, like, you have to both create a CRD in YAML format and create Java classes that map it in the application itself. We don't do anything about how to package the application in Docker or how to deploy it to Kubernetes. We rather rely on Quarkus there. That's a bit of an interesting thing where we want to support all use cases, including Spring Boot, Quarkus, and plain Java. At the same time, we don't want to build our own generator things that are already handled, let's say, in Quarkus and Spring Boot separately. So we're in a bit of we have to make a few interesting choices there. And right now we are focusing on Quarkus. So whatever Quarkus does for us, we use that, and we will go back to Spring Boot, and maybe certain things we will just not support for plain Java applications. So yeah, and currently we're working with the Operator SDK team to integrate with the Operator SDK CLI to be able to generate like a new project from scratch. But actually, we just had a discussion about that, but we're a bit wondering about how much Java developers would really need this functionality, especially since in Java, we are aiming for a very minimal code approach. So, like taking care of things with reflection and so on, without having to like have a lot of boilerplate code lying around. So, in that sense, the scaffolding is maybe less important than in Golang land. Anything I forgot about, Chris? Anything to add?
No, I mean that's an accurate summary, I would say. I mean, I just want to step back a little bit, maybe, because I don't recall who was saying that. I think it was James. But yeah, at the heart, Kubernetes, at least its API, it's a big REST API. So the way you interact with it is like you would any REST endpoint, right? I mean, you could write a bash. I mean, you can write a bash script with curl and whatever to get work done with your Kubernetes cluster, and that could possibly work. I mean, it would be a lot of work, and it probably wouldn't be that much fun, but you could do it. However, when you start working with operators, you realize quite quickly that there are common patterns. I mean, basically, when you create your resources, then, and that's the nice thing with Kubernetes, is that it's a declarative API. So you tell the cluster, okay, here's the state I would like you to be in. I don't care how you do it, but that's what that's what you need to take care of. And the fact that, I mean, it's declarative, it's quite nice because you don't need to take care of, I mean, you don't need to worry about how your desired state will be realized by the cluster. But the downside of that is that someone has to take care of realizing that state, and that's basically the job of operators. And so they need to, there are certain actions that they need to take, like the reconciliation loop and things like that. Is my resource a new resource? Has it been deleted on the cluster? Has it been updated? What do I need to take care of in that case? So there are lots of common actions that need to be taken care of. And that's where having a framework or an SDK to help with that really adds structure to your work and helps taking care of those common things. I mean, like I mentioned in my introduction, I worked with Go operators initially, and I used the Operator SDK, and that was really a nice way to get started. I still think that, I mean, it was a while ago, so maybe it has evolved since, and I think it did. There are some abstractions that I think could be added, and maybe we'll talk about that later, but that's also something that we want to take care of in the context of the Java Operator SDK. Is that right now, I think the frameworks that we have for operators are pretty good to deal with one custom resource, where basically what we would call the main or primary resource. But very often when you deal with operators, you have your custom resource that is basically your abstraction for the domain you're trying to work with. But very often to create what this abstraction means on the cluster, you need to work with other resources, either those resources that they come from other operators, or sometimes, I mean, or most of the time, they are native Kubernetes resources. And I feel that's something that we are missing in the framework world of operator SDKs, is to have a better way to handle those dependent or secondary resources. And maybe Jesús will talk about that a little bit more.
That's a nice introduction for Jesús. Thank you.
Thank you, Christophe. Yes, so to kind of tie into your comment about the libraries like Java Operator SDK and things like that, the Operator SDK that we have at Red Hat in the Operator framework, we're using controller runtime to kind of make the API easier when you're doing your watches and things like that. So instead of having to go and deal with the informers and all the low-level K8s APIs, controller runtime kind of hides a lot of that. So you can basically say, this is the resource I want to watch, and it handles that in the background. So that's the stuff I saw with the Java Operator SDK is offering on the Java side, very similar type of abstractions, which is very nice. Now, with the Operator SDK, we've been focusing on scaffolding Go operators. We used to have our own format in terms of what a project would look like. Then we teamed up with the KubeBuilder community, and we aligned with theirs. So now we have a KubeBuilder. We use their layout when we scaffold out a Go operator. But then we added the ability to do Ansible and Helm because we found that some folks said, I need to create an operator for my application. I am not a Go developer. I'm not a Java developer. But my management wants me to have my application there. I've already got a Helm install or Helm charts, or I already have Ansible installer to put it into the cluster. So with our scaffolding, we allow them to take their Ansible playbooks, put them into an Ansible operator, and easily get an operator for their application without having to write Go code or Java code or anything, but they can stick with the Ansible stuff. Same thing with the Helm charts. Some folks had already Helm charts and they wanted to reuse some of them in an operator to do the installation and the stuff. So we scaffold out an operator for them, allow them to put their chart in the right place. Now they've got an operator. But that type of the language support is a common request for us. Folks are like, hey, I'm a Python guy. I want to write my operator in Python. I don't want to learn Go and Java. Same thing with Java. Hey, I want to write my stuff in Java. So far, our sticking point has been because we've relied on controller runtime, most of our operators scaffold out some Go code and use controller runtime. So we've kind of put off Java and Python because there is no existing controller runtime that we knew of. Now that we've talked with Christophe and Adam, it's like, oh, there is a possibility, something that allows kind of the abstraction that makes it easier to try to scaffold out a project and use that without having to have all of the Kate's API rawness in there. So that's one of the things that we've done. Now, the other part that Operator SDK has is OpenShift has OLM, the Operator Lifecycle Manager, which a lot of folks are trying to distribute their operators with. So SDK has tooling built in to help them get there. So OLM uses a bundle format, which is effectively CRD, CSV, and a bunch of other YAML files. We help operator developers create those from their operator. We also give them the ability to basically run it. So you can say Operator SDK run my bundle in the cluster. Hey, this will at least give me the ability to verify that my bundle is created properly and will run an OLM. So when it does go through the pipeline and gets shipped, I feel confident that it'll work. So we've got a variety of those tools in there and testing and things like that. But we've been working with Christophe and Adam to kind of push forward being able to scaffold out a Java project for an operator and seeing what that would look like. And I know that some of the Operator SDK users have asked for that type of stuff.
Nice. And Marc, I know very well what you are doing in Jakub and Fabricate Client, and some of the guys in the conversation are using basically your tool. So what can you put here in comments?
Okay. So, well, just as Chris said, when you are building an operator, you probably have to deal with the same set of problems that other people did in the past. So it really makes sense, and I think I've talked with you, Jonathan, about this many times. So it really makes sense that there is a common pattern and to use a tool that might actually help you overcome this common set of problems. So if you are building a standard regular operator, what probably makes sense is for you to use an operator SDK. So in this case, even better if there is this support for a Java operator SDK, which Adam and Chris and so many others are building right now. And that's what, in my opinion, makes sense if you are trying to build an operator. And I also want to say that Kubernetes has a very specific definition for what an operator is. And it usually involves custom resource definitions and dealing with an application and so on. But there's also the controller pattern and other patterns that when you have to deal with Kubernetes in general. And well, I know that the talk today is the operators panel, but probably some people in the audience want also to deal with this other kind of stuff, or build their controllers, or build even some things which are simpler. So probably if you want to build something like that, you might want to go directly to the Fabricate client or to any other Java client and deal directly with a lower level of abstraction, so you can deal directly with resources and so on. So again, for me, it depends a little bit on the complexity of the things that you are trying to achieve and the level of control of the things that you want to do. There was also in the previous topic, other speakers were saying that how hard it is to synchronize and to orchestrate the deployment of YAMLs, or because it's difficult if you want to do a kubectl apply and you don't know the order, or you might need to wait for your resources to be ready and things like that. So what's stopping you from doing this stuff using code? Why you can use a Groovy script or a JBank script and use the Fabricate client directly and code your resources. There's nothing stopping you from doing that. So I think that this is also something interesting for the people to know, that you can actually code Kubernetes, right? Write your resources using code, and that's something that might be interesting for the audience. Yeah, and basically that's it. So basically, if you want to build something complex, an operator, use an SDK. It makes sense. If you want to do something else, probably use the Java client, because you know Java and you know the tools.
Yeah, I can add in that particular point that recently our team created an operator without SDK, but because it's very simple. But I think it, as a summary of all of this, is that they are tools to provide easiness to creators of operators, probably also to create a standardized way of creating operators that I think, I'm not sure if anyone put this into the conversation, but I think one of the goals also of SDKs and libraries is not also to produce easiness, but to produce consistency and produce a common way of doing things. And I think SDKs obviously help on that, but as Marc says, you also can create your operator by hand in the most simple way if your operator is simple. But in most of the cases, in order to have a common way of doing things, SDKs and all the knowledge, for instance, in operator framework, obviously are going to help people in order to not fight battles that others have won in the past. So that's also very, very important. Thank you very much for your comments. Yes.
I just wanted to add just one last point. Yeah, I mean, obviously, like I said earlier, the Kubernetes API is just a REST API, so you can do pretty much whatever you want that way. But yeah, like you mentioned, the value of the SDK is also to have a glue. I mean, kind of a glue that ties everything together, as common patterns, solve common problems, and also hold your hand all the way from development, but as Jesús was saying, all the way to deployment and production. I mean, basically, I mean, in Operator, you have ops, right? So it's not only about developers and writing control code for to deploy your application, but you also want to be maintaining them and upgrade them and things like that. So you have a whole life cycle that needs to be handled as well. And obviously the Java operator SDK is not there yet, but the goal is to help with that. And yeah, it's trying to be the glue between different projects. We, like Jesús was saying, we want to be part of the operator SDK, CLI. Obviously, we use the Fabricate client a lot. I mean, without it, the SDK wouldn't be doing much. We also work on the client itself to fix issues and improve it if we need to. And yeah, that goes also with the Quarkus side of things, to try to be, I mean, as efficient as possible at runtime, and make it easy for people to migrate. I mean, to deploy their operators once they're ready to basically go to production. So that's that's the goal.
Thank you. Let's move to the next section. Thank you. Well, we are tight on time. Thank you. Okay, for the next section, we have for events and reconciliation, we have Marc here. We have Jesús, and we have Jakub. And we have Attila. And we have Alberto. Okay. Okay, so now this section goes about events and reconciliation. So how do you organize your operator logic on the reconciliation loop, and how do you handle the events that are running on your on operator and on Kubernetes? From the perspective of the operators SDK creators, what your SDK provides to this, and from the perspective of operators creators, which is the way that you handle this. We can follow the order that I have in screen. So Jesús, Marc, Jakub, Attila, and Alberto. Your turn, Jesús.
Okay. So like I mentioned earlier in the previous thing, section, the operator SDK, when we scaffold out the project, because we're using controller runtime, the library, to handle a lot of the reconciliation and the events, we can scaffold out a controller that has a reconcile loop kind of structured already, and it uses the library based on what API you wanted to add. So if you add a resource, we will add that to the reconcile loop, and the controller runtime will handle the events and handle the informers on that side. So it makes it easier to start with. I've done it by hand, and it's a pain because you always forget one thing or the other. With like the Ansible side, on Ansible, the loop is already built into the Ansible operator. Same thing with Helm. But what we do is we give the Ansible developers a way to tell us what resources they want to watch in a YAML file. We load that up and basically create the loop based on those items. So they don't really have control over the actual loop, only the items that can go in it. But it at least is functional, and then we call out to like Ansible runner to run the specific playbooks for those things. But for the Go stuff, we do create a project with the reconcile loop using controller runtime. And that's the hope either with the Java or Python. It's very similar, give you the initial set.
Sorry.
That's it from me.
Marc, okay. Marc, what do your client does on this topic? You're mute, by the way.
Okay. So from the client perspective, well, you can go from more simplicity to higher level of abstraction again. So the easiest thing is you just poll the resource and you will eventually get the events, but that's obviously not the thing that you want. So the next step is that you open a watcher connection to a resource, and then you will eventually receive events. The downside to this is that you will, maybe if you want to watch the same resource for several purposes, you will end up opening many watchers for a single resource or something like that. So the next step in levels of abstraction is using the shared informers. This is a concept that was ported from the Go client. So basically here, what happens is that there are watchers open for each of the kind of resources that you want to observe. And then you can register a set of listeners, and then each time there is an event, you will receive a notification in these listeners. And more or less, this is it. So again, if you are building something which is not an operator or something more simple, you might go by using this. But obviously, if you want to start doing things that are more complex and so on, you probably want to move forward into the operator SDK, which I think Attila will give us more details. So.
Attila, want to go first before me to kind of follow up on that?
Yeah, sure. I think that will be reasonable. Okay. So as Marc explained, we have this layer of abstractions and tooling. Then we are receiving events from Kubernetes, basically API. And yeah, we are basically have the most primitive and but efficient ways to do it with watches. And then the Fabricate client is doing informers, which does it a little bit more intelligently. And so we on the Java Operator SDK, basically we are building a whole other layer about this and solving some kind of a common problem. So, and it's not simple in a way that basically in the heart of this operator is just an eventing system. From that point that we receive an event from Kubernetes API, we want to usually react on that event, execute this reconciliation method loop. And what happens is that in the reconciliation, we want to check the resources which we are managing, and we want to create them, update them, and do all kind of operations on the resources we manage with the operator. So the complexity comes when actually we want to also watch for these other dependence resources what we created. Then there is this, we can register something called informers and operator SDK, but in Java Operator SDK we call it event sources. When we say that, okay, we created this resource on Kubernetes with the operator, but we want to also react on changes and maybe fix some problems that's happening with that particular resource. So then it gets quite complex, and then threading is involved and all kind of consistency issues. And all these issues basically to be solved very nicely and user-friendly way, that's where the point when you need basically a framework or an SDK, mainly framework to handle problems with concurrency, lockings, these event sourcing triggers. One particular interesting aspect is, yes, this is an eventing system, so we receive events mainly for custom resource changes, but also maybe from events from the other systems we are watching with the operator. The interesting thing to think about is that these events can be lost, the operator can be down, and all kind of situation, which basically also we are solving. And there are all kind of debates now that how we use these events, if we use at all. And we claim that basically inside a controller, you shouldn't really use events. You just always reconcile the whole state of the whole system you are basically operating with operators. That's a bit advanced topic, but yeah, that was our current or my conclusion, at least.
But it's very, very interesting that topic for sure. Jakub, what can you say from the Streamzy operator?
Yeah, so the way Streamzy is done is that we kind of combine watching for events with having something what we call periodical reconciliation, where basically we watch some of the basic resources like the custom resources and so on. And obviously we do the reconciliation when something changes with them. But we also have, by default, it's every 2 minutes, where we basically trigger the reconciliation loop just by a timer. And make sure that everything is in place, everything works fine. I don't think that's that traditional, what other operators are doing as well. But one of the advantages, I think, is that especially when we operate some of the resources not necessarily inside Kubernetes, but for example, inside the Kafka itself, then this periodical reconciliation basically allows us to deal with this regularly and in reasonable time, even without necessarily having the ability to set up some watch for them. Because that's one of the nice things is that as long as you stay in the Kubernetes API, it's quite easy to have a watch and get the events. But once you get out of it, that's not always as easy as with Kubernetes.
Could I react on that a little bit?
Yeah, sure.
So yes, I mean, we recognize this pattern, and I think people are doing this way, that you either have a periodic reconciliation. And I think this is one of the so for sure, if you even created or somebody created all the resources what you want to manage, the life doesn't end. Like it ends probably to some extent with Terraform or something. The resources are there, but we want to also check on the resources. So, and one of the ways to approach this way, to do it periodically, or reconcile the whole resource periodically. And but also we can do this kind of a local change detections, like then you don't have to execute the whole control. And this, for example, these are one of the patterns we recognize that might help a little bit more optimized way is to do it within these event sources, check periodically some resources there, and not reconcile the whole controller just when there is some particular sub resources changed. So yeah, that's a way to, I guess, to do that too.
Yeah, I think one of the challenges for us is that sometimes the state of the Kubernetes resources kind of ties in, for example, for the configuration. So reconciling just some part of it is not always easy. I don't know, for example, if address of a service changed as a load balancer service, then basically we need to, because of how Kafka has its own discovery mechanisms and so on, we need to make sure to reconfigure the Kafka itself. So yeah, I think sometimes it might be easier enough to do it on a small part. Sometimes it's maybe just easier to run it through the whole piece.
What I meant is actually we always again running it for the whole piece. Just when we are running is a difference. So what triggers that run? So yeah, that's not necessarily whole loop, but the trigger might be local trigger, but it runs the whole reconciliation. But yeah, I mean, you're absolutely right that reconciling just a part would be kind of a complexity. I think that unnecessary.
Alberto, the stage is yours. Last but not least.
Yeah, so we are using a different approach. We are using the official Kubernetes Java client. It's kind of nice for us because it's very easy to integrate with the tools that we use. We get some annotations and interfaces, so it's very trivial to know where the events are coming from. Also, it's just an annotation away for you to create a shared informer and reconcile the resources that you want to reconcile with. It also has a really nice Spring Boot support. We are actually contributing within some time. It also comes with a generator. So as people are talking in the chat, we are actually generating the CRDs. Generating the classes and the clients from the CRD definition. And we really like that because we have one source of truth, regardless of the schema. So we are using that pattern, and we found that very useful. It's called generation, but it is what it is, I think. And what else are we doing? So some things I would like to know, just for other people that never did this before. When we are, for example, we are adding statuses in a CRD subresource, and it's actually the same generator generates that for us. So it helps us with the client as well, just all the calls that we have to do to update all the statuses. Also, we generate events on the same loops. Finally, on delete, we do a couple of tricks. So first, we just use our references. So most of our deletes are an OOP, really, because when you delete the CRD, everything under the hood is going to get deleted. And one thing there's one case where we have to pause a little bit our deletion. So we're adding a final asset on creation. So then when the deletion gets triggered, we have some extra time to do what we want to do. And that's some patterns that we didn't know when we started with.
One thing that I found also interesting is that in some cases, as Attila also mentioned before, there's a controversy here, but based or not based on events. But when you are based on events, even if you are based on the picture, sometimes it could be interesting to know the delta, so the differences between the previous definition of your objects, of your CRDs, and sometimes this is not very well provided in some cases, and there are some tricks like using labels or annotations to store the previous version. But I think this is like more a workaround than a real usage. So if you end up using that, it's because well, the platform hasn't thought about this usage, right? So yeah, sometimes you end up seeing that when you start using this or creating operators, it seems like there are some things still missing in this CRDs conception, because there are there, but sometimes if you want to, so you are using data to trigger operations. So if you want to trigger an operation, you could just simply create a CRD to trigger an operation on your operator. But it could be that the system provides a way of telling the operator, okay, execute this operation, because you have all the logic inside. Well, I don't know. There are several things that well, in my super little experience, I found that there are some things not very well defined, or because probably it doesn't have the maturity of well, no many years have passed on this.
Maybe I can
yeah, sure.
react on that a little bit, just a small piece. So
yes.
yeah, I think most of the things that maybe are openly defined, like how to use statuses and the status sub-resource, and basically that's the place when you mark that this was created and that wasn't created. And if something changes in the spec, you can combine the status and the spec and maybe react based on that in terms of custom resources. But I think you're right on maybe some external resources. This is maybe not that simple, and you have to extensively use lots of data to put in the status regarding to that external system. And yeah, but I think it's open defined. Maybe there are some patterns to follow and to discover yet. Yeah, that's it for me.
Okay, so we are run out of time on this topic. It's been super interesting. Thank you very much, because I'm learning a lot. Okay, so we are going to move to the next topic, that it is testing. Very interesting. I'm going to politely kick off some of you, but see you in a minute. Okay.
Adios.
Okay. So for this, we don't use Jesús, we don't use Marc. We use Jakub. We use Álvaro and Bella. Hasta luego, Alberto. And you, Attila. Oh, I need to kick off you too. Okay, so let's go for Adam. Álvaro. Well, I have to say that this way of removing and adding people makes me more focused. Well, makes things a bit more interesting. Testing. Bella. And Jakub and James. Okay, for testing, we have also 15 minutes, and we can just simply go around the panel on my vision order. So first is Jakub, then Adam, Álvaro, Bella, and James. We are going to talk now about how did you test your operator, and if you are involved on an SDK framework, I think I'm pointing to you, Adam, what your SDK is offering for testing. Okay, so let's begin. Your turn, Jakub.
Yeah, so since Trimzy doesn't use any framework, at least not yet, pretty much most of the testing has been done by us or by our amazing QE folks. And I would say it's kind of can be split into 3 different parts. One of the big challenges with Kafka is that you have Zookeeper, you have Kafka, and now to test things properly, ideally you need to have more of them because you need to test that the cluster works. So one of the challenges is that it's not exactly cheap in terms of resources which it needs. So that's why we usually try to have fairly good coverage with some mock tests, either by using really just some mocks of the internal Java classes, but we also use, I think it's basically using one of the features from the Fabricate client that it basically mocks the Kubernetes API itself, and you can really use the methods to create pods and stateful sets and config maps and secrets, and it all kind of works as with real Kubernetes. So we try to use this always as kind of the first line to catch things as early as possible, and then as the second line, we try to use basically Minikube and test it there on one of the CI systems which are available right now. We are using Air pipelines, which seem to work quite well for us. And then the third stage is basically kind of trying it in a proper cluster, not just in a small Minikube running somewhere with few gigs of RAM, but going into a real cluster with real storage and things like that, and real load balancers. I would say the biggest challenge is, especially as an open source project, is that a lot of these things can get quite expensive quickly, especially if you would test everything in some AWS cluster or something like that. So that's why kind of we try to have this more staged approach to catch the bugs early and not necessarily run big cluster for every PR and things like that.
Adam, and what the SDK can provide to people?
Yeah, not much.
Okay.
The top piece of functionality we never really got around to, but there are, so basically the SDK itself is unit tested. We also do tests with Minikube for the SDK itself. The operators are really tightly intertwined with Kubernetes, right? Kubernetes API, which that can be mocked with Fabricate, but then again, if you want to actually test like what's happening and so on, it's more difficult. We use finalizers for making sure that delete events are handled properly. So mocking all this would be very difficult. I could imagine this to be like a future feature of the SDK where we would provide something like Spring provides mocking for a web server. It will be difficult, and the value is a little bit questionable because you can fire up Minikube and run tests on it, or on an all the time running Kubernetes cluster. So I wouldn't say it's questionable in the sense of, yes, it would definitely make tests faster and so on. So it's always better to not have to rely on external infrastructure. But compared to the cost, we don't have it currently even like as a next step or something. However, if we will have users begging for this, and we will definitely bump the priority. And we do have one pain point which we have not addressed, is the testing of our own samples, basically. And there the plan is still just do it with Minikube, basically, instead of like trying to do some really sophisticated mocking. Yeah, that's our story, basically.
Okay, and Álvaro, how do you test your mega operator?
Yeah, it's a good question. If you would allow me, I will also bring some quick feedback about the reconciliation part, because this may be interesting for the SDK for developers. So first of all, I would recommend you to just have a look at our code or ask any questions in our Slack channel if there's some questions about it, because I believe it might not fit the usual pattern, or maybe yes. But for example, to name some examples, we don't have a one-to-one mapping between CRD and controller. We actually have 8 CRDs and 1 controller. So the controller is controlling all the CRDs. We don't use any code generation because actually the CRD spec is quite complete. Documentation is very extensive with even markup language, has validators, has regex, has enum types. It's quite complex, and if we would just generate this from Java annotations, it will totally mess up with the code. And so we generate the YAMLs, the CRDs independently. We are planning also to have what we call pod local operators, or controllers. So basically, we have a main controller, but then we need to execute operations local to the pod that, as of now, we're doing like firing a job and doing a kubectl exec, which is not the best practice. And so we want to access the local file system from the pods and execute actions locally. So we're going to have like these mini local controllers, which are going to be watching on part of the space of the CRDs. So it's quite of a significantly unusual patterns that we're using because it's quite complex everything. So it's probably a good look for any operator SDK developers. Also, we have our own internal framework. Actually, if you go on source code, there's a folder called Operator Framework. It's not 100% abstracted away from Stackgres, but it's pretty much. I mean, with a small effort, should be well abstracted. Could be a framework by itself. Maybe still specific to us, but could be extracted away as a separate module. We don't have the time and resources for doing that, but could be a great example and does all these. For example, the reconciliation cycle that we do is I would say, in general, quite advanced from the perspective that it's not just, oh, this is a reconciliation cycle, just go and do something. But actually, it presents you already with an iterator, kind of a visitor of all the CRDs that you have on one side and all of the real resources you have on the other side. So it's basically just saying, okay, this is a CRD, this is a resource, let me know what to do with them, but you already constructed all this information. So there's a lot of stuff built in there, and we're happy to share that with all the operators and community and so forth. About testing. So we use 3 levels of testing, 2 automated and 1 manual. The first one, automated, is pretty simple. Unit tests, regular Java unit tests. They run very fast. We have over 500 unit tests right now, and it covers small parts of the code. The main layer is the end-to-end test, E2E. You can also find them, of course, on the source code. And this is where we perform most of the heavy testing, because for testing a Postgres operator, we need to fire Postgres clusters with a primary, with replicas, with clients. And so it's far from trivial to fire up all these environments. These E2E tests are written in mostly shell scripts, so I don't think they're very useful for a Java SDK as of now. And probably they're very specific to us, but basically they support many Kubernetes real environments, even though we use kind by default, but we also use to test real clusters, EKS, AKS, OpenShift, all within just passing some environment variables, and then it will run on different environments that you may have constructed or not, you want to recycle them or not, and some other variables. But we have implemented around 50 end-to-end tests, which, like kill a node, do a failover, verify that there is a primary that is fired up elsewhere, that if you're accessing the service from the read-write endpoint and there's a failover, you still get a read-write connection. That they're simulating advanced scenarios, and they all run on every commit. So they're on our pipeline, and every commit takes 1 hour or more for just a deep validation on that. And then for releases, we obviously do manual testing. We fire real environments on cloud environments and test them there. But yes, it's a cost factor. We're actually also concerned about this. We've done small amount of work. I'll share the link right now about some hackish scripts that we've been doing to being able to fire up whole Kubernetes clusters on-prem on your laptop by creating lightweight virtual machines with Firecracker. So it's basically a way to run a whole Kubernetes cluster. We've tried actually, for example, running EKS, they're now open source, on your laptop with many nodes running on separate virtual machines, and all this automated and scripted just to be able to also make this testing on real clusters, not kind or anything like that, with real storage easier. I'll search this link if it's interesting, but this is a complex problem.
Oh, well, what I'm thinking is that I will ping you later. I will ping you all later, because we can arrange a one-to-one only meetup for everyone, because I think you are saying a lot of very interesting things. What about you, Bella? How do you test your operators?
Yeah, so we have 3 levels of testing as well. All of them are automated. Like first level is unit test, of course, like everyone does. But we make sure that in our unit test, we don't mock any API servers. Well, we don't do any actual K8s API interactions, because we wrap them in an external layer and then we test that separately. And we test those parts that actually interact with API servers with kind. So we're getting the real response from API server, not just the mocked one that we think it will work, but we don't actually sure. And when we do component tests, that's the second layer, we're still running with kind. And then at that time, our operator is running in JVM. We're using Spring Boot test, so we can change the properties really easily in just the normal component tests, and still getting the responses from a real, well, not real, from a local kind cluster that's relatively more real than mocking. And the last layer is the acceptance test, or end-to-end test, like some of you said. They're written from a user's point of view. We will deploy our project just as our users, how our user is doing home install into the cluster. And then we are running against the real real Kubernetes environment, TKGI, previously known as PKS. It's like VMware's GKE, and there's some tooling internally that provisions cluster for us. So it's relatively easy for us to get a new TKGI environment for our testing. And on CI, we use GitHub Actions. And because our code is proprietary and private, we have to use self-hosted runners. And each runner will be bundled with a dedicated TKGI cluster, so many builds can run in parallel. And our CI is running for every commit in the main branch and all PRs. And they all run at the same time on different runners, so no interference between them. We also have CI pipeline for upgrade test. So install the previous version and then run AT and then upgrade and then run AT, making sure the whole flow is working. We also have Dependabot to automatically update dependencies and create PRs whenever the dependency changes. And we're planning to release our operator in native image going forward, but we're not focusing on it right now. So we have a separate pipeline that runs nightly and compile our code into native images and run the same sets of tests on those images, making sure everything still works. That's our testing setup.
Definitely, I will ping you later too. James.
That was awesome. That was awesome.
Oh, yeah.
But by the way, a shout out to PKS. So PKS is an operator for making clusters. And we should maybe mention another operator, like it uses the cluster API, the Kubernetes cluster API. So there's an operator that lets you make clusters, which is kind of cool. I mean, there's versions of this that works on all the different clouds, but there's an operator to making clusters, which is pretty cool. Anyways, testing in our world is very similar to everything that's just gone before. There's unit testing. There's the kind of using kind to do pretend testing when there's no real cloud infrastructure, but it looks like a Kubernetes cluster. An interesting observation, by the way, in Go worlds, we don't talk about mocks. We never use the word mocks. We use fakes. Fakes look and feel like Kubernetes. Mock in Java land means you use mocks. You say, if you call this weird thing, I'm going to tell you if it called that method, which is terrible. I hate mocks. So I hate Java mocks. Fakes are awesome because they look and feel like the real thing. Anyways, but they're kind of similar. The interesting thing we have that most of our testing is not so much, does this work in Kubernetes or doesn't it? It's, does this work with Azure and EKS and Google? And it's worse than that. It's, does it work with Azure with Azure Secret Manager, and using this container registry, and using that artifact repository, and using this other thing. So a lot of the CI/CD operators we deal with, even if we had the world's best faker that could fake almost everything that exists, it doesn't catch any of the real issues that cause problems like, I don't know, a new version of Cert Manager will break with Nginx and on Azure if you're using Azure Secret Manager. It's like those weird integration problems. So most of our testing is really unit tests and integration tests, and the bit in the middle is of limited value for us. We find really testing for with real cloud infrastructure is where we get the best bang for the buck. So it's either mostly unit tests or it's real. However, it's usually temporary real. So I mentioned before, we use the Terraform operator. So we just spin up real cloud infrastructure. So whatever it is, the infrastructure we need. So it's, buckets, KMS, it could be Vault, it could be Azure Secret Manager, Amazon Secret Manager, Google Secret Manager, like all that cloud stuff, all the real infrastructure stuff, and the Kubernetes cluster. We find issues with different pods, machine types in Kubernetes, issues with different memory, with different GPUs versus Linux versus ARM versus AMD. So we find all of the thorny problems are on the cloud infrastructure layer. The beautiful thing about Kubernetes is everything looks and feels the same wherever you run, which is awesome, but that doesn't mean it's going to work. It's a bit like the old days of Java, like write once, test everywhere. The cloud is the test everywhere, that you've no idea if it's going to work until you actually try, that cloud provider, that storage disk, that network option, that VPN, that autoscaler, that whatever. So most of our real heavy duty testing, we love fakes, and that's a great way to test, unit parts of your system and fake out everything else. And that catches a lot of bugs. But most of our time spent catching issues outside our code base. So it's, Cert Manager has changed slightly, and that breaks our TLS, and that breaks our, ELB in Amazon or whatever. So it's the cloud side that's the trickiest. I am hoping as an industry we can all get better at this. System testing. Another thing I'll just mention very briefly is, so we found there's a million versions of things all through the stack. Like which version of Kubernetes are you using, which version of Secret Store, which version of all the different Helm charts you use, all the different operators have versions that are changing all the time. We found even just knowing which versions of thing works is non-trivial. So we made a little thing, we call it a version stream. Basically a Git repository of every container image, every Helm chart, every operator, every Terraform module. Like we just put everything we can think of in one massive Git repository. And then any test uses the exact versions in one Git repository. And then if ever we're going to change anything, like I'm sure changing Nginx is not going to break anything, isn't it? Like it doesn't matter what it is. Anything you change, it seems innocent. You make a pull request on this one Git repository, and then all of our tests trigger. So we know, because it's so easy for anything to break everything. And often it's things you would least expect, like you've switched your JVM image or something. Like, what's the worst it could do? Like 12 was fine, it's gonna be amazing. But almost anything can break everything. So we find that locking everything, always use a version. You version every image, every chart, every operator, every piece of YAML you've ever seen. Version everything, put that in one big ass Git repository, and then automatically system test everything. Now, because we don't have infinite wallets, you might not be able to test every change individually. And you might have to do the git bisect thing of, I've changed 20 things and I'm going to test all those 20 things together. Do they work? Phew, that's awesome. Oh, they didn't work. Oh, okay, I'll roll back telling them, does it still work? And you might have to do the git bisect of figuring out which was the thing that break, and sometimes you don't test every single change and you just test lots of changes together because it's cheap. So you might do like a, I don't know, an Azure test once a night, once a week. You might have done 100 commits that day. So we have to do these optimizations because we can't quite afford to test every single thing in a system test. But testing is a challenge. But I think definitely unit tests and mix, awesome, kind, useful. Then you need to automate real testing on real environments. I mean, sometimes you can just have a shared cluster you use for testing. Like if you're just testing a microservice, your life could be quite simple. You just have a test cluster that's there all the time. But really, you want to test. I think having a single test environment is scary because it's locked, and the whole world is moving all the time, and you're stuck on this old version of everything, and you don't change anything, and you just test your microservice. You don't realize that your stuff's breaking for all your other users that are using, the latest cluster that gets created. If you're cloud providers change their Kubernetes versions every 3 months usually. So you want to be creating new clusters again and again and again, because then you will find the bugs that get introduced by new clusters. Anyways, yeah, bit of a ramble, but yeah, Kosuke is doing some stuff in that area too.
It's super interesting. I'm going to move quickly to the deployment and publishing. We don't have much time for that topic, but we will do what we can. I will kick off some of you, but please come back at the conclusions in the end. Okay, Adam. Alberto. Okay, James, you are staying. Bella, see you in a minute. Álvaro, you are staying, and Jakub. Okay, see you in a minute. I will add Alberto. Also, I will add Chris. And James. Okay. It's between us. Okay, let's wait for Chris to show up. Okay. So we don't have much time. It's only about 1 minute to everyone. Sorry, but it's what it is, a panel. Okay, about deployment and publishing, brief explanation of tools, Helm, Jakub, any other, format, YAML, JSON, any other, and repositories. Helm Hub, Operator Hub, do you deploy there or are you planning to deploy there? We can just go first, Álvaro, James, Alberto, and Chris.
Just quickly, I actually don't have much to say on this topic, so maybe Jesús would have more to say. I think it would be more pertinent.
Okay, I will put him. Okay.
Okay, so I'll go. Try
Yes.
to be fast. We recommend Helm. We produce Helm charts. We also support command line kubectl apply -f giant YAML file, but that's just for demo purposes to make it quite simple. Helm has a lot of parameters, so you can tune the installation. We're self-hosting it right now, self-publishing, but we are planning to host it on Artifact Hub and Operator Hub. Now, a quick note about deployment, because we are focusing a lot on what is called day two operations, so not only deployments. And we're bundling actually a CRD called SGDBOps, so Stackgres database operations, which is brings around 8 operations automated right now. So you can also just write a YAML file to run operations on the database, day two operations. And last, I wanted to mention that one thing that we have developed for this kind of internal SDK framework that we have is that we have done a lot of effort related to upgrades, which is also related to this cycle, right? And so we support basically upgrading the operator, but basically our resources, mostly pods, they are stateful and they don't like to be disrupted. You cannot just say, oh, we're going to restart Postgres, because that causes downtime. Even if it's seconds, it is downtime. It's normally not acceptable. So we have developed a mechanism where we can have our operator being upgraded already to a new version while keeping the reconciliation loop working well for clusters created with older versions. So basically, we're using conversion webhooks so that when the resource is read from the metadata, it's converted into the new version, which is the version that the operator supports, and performs the appropriate actions. And then we defer control to the user to when they want to upgrade the physical resources to the new CRD version in an appropriate way. This also has led us to introduce compatibility matrices, so to make sure that we can upgrade from this version to this version. Otherwise, we will not allow to upgrade the operator, and a few others. It's actually what's been one of the most significant developments we've done in the last months. It was very complex topics because we have to deal with a lot of resources, but at least I thought it's a solved problem right now, and it's quite powerful.
Interesting. James, what about you?
I'll go quickly. So similar, we recommend Helm. We think Helm's the easiest way to package your stuff. Some developers kind of don't like Helm and they kind of prefer kubectl and stuff. For me, it's about consumers. Package your stuff as Helm and then anybody can install it really easy. If somebody really, really doesn't like Helm, they can type Helm template, they get the YAML, they can type kubectl apply. So Helm's like an absolute no-brainer. It makes it really easy for those who like Helm. For those people who don't like Helm, it's trivial to also make a YAML file with all the output of Helm for kind of people who hate Helm for whatever reason. In terms of container registries, we're using Google right now, and we also use GitHub. We're kind of thinking we should just go all in on GitHub container registry for publishing images for people to consume, because it seems to work great. But we kind of use both those too. I think I mentioned this earlier. One thing we found, because we, rather like you just mentioned, it's all about doing it. It's not just installing, it's about upgrading, and how do you kind of keep on top of all these things and operate these things at scale. We found something really useful, and one thing we do internally with JegExec, and we recommend everybody else does when they use operators. If you do Helm install or customize, apply, or any of these tools, there's magic in there. There's magic that does stuff, and you're never quite sure what's going on. We're huge fans of doing Helm template and getting that YAML and checking it into Git. Because there's all these different tools. There's Helm, there's kept, there's cap, there's customize, there's kept, which is KPT, which is another tool. But there's all the different tools. There's Helm X, by the way, as well, which kind of combines them all together. We use Helm file a lot, which is a wrapper above Helm that lets you install multiple Helm files. All these different tools work in different kind of ways. And as a developer, it's really hard to understand exactly how all these things work. Like when you have lots of different Helm files and template files and Helm charts and a big tree, it's quite hard for us to look at Kubernetes and understand, where did all this come from, right? I've seen 10 resources here. Who made them? How did they get, when did they change? And this works with any GitOps tool, right? This works with anything. But by essentially doing Helm template, taking all the output, checking it into Git, it means you might install something and then 3 weeks later you realize this one deployment is failing. Why is that one deployment failing? That deployment resource, show me in Git the history of that one Kubernetes resource. And you can look over time. It doesn't matter what tool you're using, right? kubectl, shell scripts, Helm, customize, Helm file, any tool. If you just get them to output Kubernetes and check that and sort it nicely into a tree, so it's not just gobbledygook, right? So you have a tree of all of your applications in your charts, and everything is versioned in Git over time. You can see what's going on and you can fix things. And it doesn't matter what tool is doing the generation and what package manager you're using. You can look at Kubernetes and you can look at Git. And when you find something that's wrong, you can look at the history. And sometimes it's not the thing that's changed. It's another thing which is secondary. And you can go, maybe it's not my deployment. Maybe it's, when did Nginx change? Oh, yesterday. Maybe it's Nginx. So it gives you that traceability to understand what changed, how did it break. If you're just staring at Helm files or customized scripts and stuff, I mean, it's tricky, right? So check everything into Git and it will say, apart from secrets, don't check secrets in, that's the only one exception. Check everything into Git apart from secrets, which is where the external secrets kicks in. The external secrets means you can check in external secrets, which are CRDs which don't have any secrets inside them. They just say where the secrets are. So this secret is in Vault, this secret is in Amazon Secret Manager. So you can check all of that into Git. And then you can version it, you can understand what's going on. So that's my tip. Use Helm, it helps your customers. Check everything into Git. And then you can help over time understand why things suddenly break. Okay, so sorry for the long rumble.
It's very very interesting. Alberto.
Yeah, I'll go next. So we started very simple. We started using Customize at first. It was the easier for us as people developing. But then as we went along, things got a little bit more complicated. At first, it wasn't even an operator. It was just a few Java apps that we just manifest and package. But obviously, things got more complex. We had the whole pattern. We have CRDs. So we're using Helm right now. with the dependency between the CRDs and everything to make the request easier. But it looks like we are going to actually move to the Carvel tool suite, because even though right now everything is very simple, we're going to start adding set manager, and we're going to start some dependencies in between our own CRDs and the things that we're going to have to create to have a fully stable environment, because we're going to have to be integrated with more CRDs. So it looks like we're going to have to be moving to the Carvel tools. We are going to share the links there. And then what else? So we are using cloud native build packs in order to create our images. It's actually very nice because it supports like the regular Spring Boot application and also the native image ones. So we can just use one tool for both of them. It's completely transparent for us. We just say, run this as a native image or run this as a regular app, and it works for us very well. And we're pushing the images in Harbor, which is as well another Cloud Native Foundation project that is open source. And it's really nice because they have all this dependency registry that is checked for vulnerabilities, and you can have it on-prem. So you're not doing open source stuff. It's also very nice. So that's what the one we are using. And I think that's a good summary, because everything we upload is called Tansunet, which is the VMware. Is right now the product we're building is for private VMware user, but we'll see where we go from here.
Okay. So from the Operator SDK, and sorry, my dogs are having a fun day. We've got, because we're focused on the developer, we scaffold out a makefile in all the projects. And in the makefile, there is a make deploy, which will deploy your operator into the cluster for testing. We also have the ability to build the operator bundle so that you can deploy that using OLM. And then Operator SDK has a run bundle command, which you can, when you run make bundle, you've got your image of the bundle. Now you can say Operator SDK run bundle, give it the link to the, give it the image. We will deploy that into OLM, into your cluster, so you can test it. For a production aspect, those bundles that you generated can now be added to an index to be put into a production cluster. So we've kind of given you the ability as a developer to, hey, let me test it real quick. So make deploy is kind of the, I'm testing in Kindy, I want to do real quick, hey, does this work? Yep. Okay, keep going. And then you want to say, now, does this next phase, does it work in OLM? Because that is my target for OpenShift. Build the bundle and do it that way. So those are the pieces. We also, the makefile that we added also works in Ansible and in the Helm operators. So make deploy target will be there, and the run bundle will also be there for all of them.
Very, very interesting. And I have to say that publishing in Operator Hub was super easy. Just creating the new bundle version and just creating the pull request, and blah, your operator is over there. That's awesome. Okay, so what I'm going to do is simply add one person. I will add Marc, and that's the moment where you have to say goodbye. We've run out of time, and I'm super thankful for you to be patient and accept to run extra time. So please, very quickly, just simply give your highlight of the event and your recommendations. Thank you very much. Álvaro, you can go first, and we can follow that.
Okay. Just thank you very much for being here, all the people for attending, and all the panelists. I just wanted to say that we have developed, I would say, a quite complex operator using Java. Without using any framework. We have relied obviously on Fabric 8 and Quarkus and a few other tools, but we are happy to share what we have done, our knowledge, our own mini internal framework. Happy to collaborate. Just ping us, and for also, if you're interested in Postgres, just give it a shot. It works very nicely and doesn't require you to have Postgres expertise.
Thank you very much for being here. James, your turn.
Thank you. This was awesome. This was really good fun. Check out all of the links in the chat. They're all amazing. There's been some excellent open source stuff in here. Everything everyone talked about today has been really interesting and deserves further research. And if you want a quick way to install lots of operators, Jenkins X does it all for you. You just need to put in your credit card to use the cloud, and then you're good to go. But pick anyone you like. OpenShift, Amazon, Google, Azure, it works. And Minikube too, if you don't have any money. Have a great weekend, everybody.
Yeah, the same. Alberto, your turn.
Yeah, so thank you so much for everyone. It was really great learning so many things from you all. So my recommendation with your starting thinking about creating an operator, you need to start very simple. Don't try use all the tools. Go your own pace. It's fine. Just start, it's customized the simplest. Just use that. It will come after, whatever you're going to use next. Scaffolding was a problem for us the first 5 hours of the project. After that, just became, where to add this annotation, or where to add these things. So don't really overthink these things. Overthink how to test the things, because that's, think about that the day one or the day two, because then you start building architecture and not knowing how to test things, everything is gonna start consuming a lot of time. So that will be my advice. Think about testing day one or day two, and don't worry too much about all the tools. Just, they will naturally flow to you, not the other way around. Thank you.
Thank you very much, and it's been a pleasure to have you here. Jesús, your turn.
Oh, thank you. Thank you guys for having me. This was great fun. And from the Operator SDK, we would love contributors if you want to help out with the Java plugin and grow that community on the Java and Operator SDK side. That would be great. The links are in the chat, or you can just Google Operator SDK and you'll find the project sites. Really appreciate everyone. Thank you.
Been a pleasure to have you here. Marc?
Okay, so thank you everyone for attending the panel. Personally, it's been a real honor to be amongst so many talented folks. It's amazing. And yeah, as I said in the beginning, I want to invite everyone to join the Fabricate community and to contribute to the Kubernetes client. This is the main target. Okay, so thank you.
Thank you a lot, guys. See you at another time.
Adios.
Adios, Jesús. Okay, so now we are going to invite to the stage Adam, Attila, Bella, Chris, and Jakub. Okay, we are the second bunch of people. It's been a pleasure to have you all here. I've learned a lot, and it's been more than 2 hours. So I'm very thankful for you to be so patient and wait for more than 2 hours to be here. So it's the time to say goodbye, and we are going to follow the order on my screen. First is Adam, say goodbye and give, suggestions to the audience.
Yeah, thank you, Jonathan. Thanks for organizing, and it was really great to have this panel. I think we need to go way deeper in these topics in some shape or form, because right now what I'm seeing is that the Java community has not yet fully embraced operators in the same way as the Golang community, while at the same time we have a lot of fragmentation already with people building mature operators without frameworks. So, and I do think that having a strong framework is really important, especially to grow this community, to bring more people into the fold, because of course you can invent everything and build great things without it. But for new users to growing this community, I think it will be really important. So just for people to see that, yeah, there is something where I can more easily get started and so on. So yeah, please everybody, let's continue this discussion somehow. And also, if you would like to contribute to join our chat in Discord and so on for the Java Operator SDK, we are very welcoming, and we would love to have people there.
Thank you very much. It's been a pleasure to have you here, Adam. Your turn, Attila.
Yeah, thank you very much for inviting me. And as somebody said before, it's, I think, easy to start with a small informer to work an operator. And if you want to kind of dig deeper in these distributed language, distributed system problems and Kubernetes API related details, and then just contact us on Discord. There is a huge pile of issues, optimizations, features that we plan for the future for the Java Operator SDK. So yeah, it was good to be here. Thank you very much.
It's been an honor to have you here. Thank you very much. Bella, your turn.
Hi, it was really amazing to be here and to hear all of the amazing opinions and stories, solutions, the links. Oh my God, I need to spend my whole afternoon checking all the links. I don't really have other things to suggest. Just read all the links, keep your eyes open, keep your ears open, listen to suggestions and patterns, and let's build awesome software together.
Thank you very much. It's been a pleasure to have you here. Christophe, is your turn.
Thanks for having me. We spent more than 2 hours discussing operators, and yet I feel like we've barely scratched the surface. There's so much stuff to learn from. It's been very interesting. Yes, I think we probably need to have another panel, another 2 hours or maybe more, to address all the issues. And yeah, sometimes for the operators, a good question to ask is, first question maybe, is do I really need an operator to start with? Maybe that's the first question that people should be asking. And then, yeah, start small, and like many others have said, it will come to you as your needs evolve, and I'm sure you'll find good resources to get going. And yeah, thanks a lot for making it happen, and it was very interesting and nice to be here with you tonight.
Okay, thank you very much. It's been a pleasure to have you here. Jakub, it's your time to say goodbye.
Thanks for organizing this, and thanks for having me here. I think it was a great discussion, and I think the best thing about it is that I still remember when we started, everyone was looking at us like, what, are you crazy? Operators in Java? You have to do that in Go. So it's great to see the progress and all the progress which will still happen in the future as well.
Thank you very much to everyone. It's been a pleasure, and I hope to see you in another moment. Thank you very much. And okay, thank you to everyone for being here and to wait for more than 2 hours. And yeah, it's been a pleasure to host this event. There are a lot of links that you can follow in the chat. And well, I also want to thank my colleague Abel that has organized this agenda. And well, thank you very much. I don't know if you have anything to say, Abel, about how this event was, and well, say simply goodbye to the audience.
Yeah, first of all, don't invite me as a surprise. I try to stay hidden for a reason. And especially thank you, everyone. Apologies for the small inconvenience we had with the assistants and everything. And we hope we all enjoyed, and we will try to collect the links and the key information and see if we can summarize it in some way. Because it's been amazing, especially the chat.
Yeah, too many links. Okay, so thank you very much to everyone, and we hope to see you in another session of Barcelona JUG next week. Thank you very much. Bye.